Oh, welcome back to the table where I fix stuff. This is early 70s, I'm not exactly sure what specific year. Magnavox portable color hybrid TV. You can see I've kind of already been in here, just did some preliminary checking out. Can take a look at the back in a minute. This is 14 inch. It's a color, it's a Delta gun. So on the front we've got color and tint, UHF, VHF of course, and then down here brightness, contrast, and vertical. On, off, and volume. You can see this is broken. You can take a look at that in the back. So now around on the back, so our picture tube here is our 14 VAEP22. That's a Magnavox tube. You can see the logo there. Like I said, it is Delta gun. It looks upside down though. I think usually they have like blue on the top, but looks like it's blue on the bottom. And it has to, the tube is not upside down because the high voltage cap is on the top. Just looks like they put their guns in differently than usual. Anyway, you see the convergence assembly there. This will be the purity magnets here. So the tube's pretty dusty. See what I'm doing, clean some of that dust. I don't really see anything in there anyway. So you can see we've got a couple tubes down here. We've got, I think that's the damper tube, horizontal output tube, little oscillator all the way down there, high voltage cage, vertical output transformer. This board here I think is all transistor. There's a couple more tubes down and under there for vertical. I think the color demodulation is also a tube in this. Got the tuner up here, and this little sticker came off. It says the tuner is assembled in, well, maybe you can read it, Hong Kong, and they didn't fill out what percent. I don't actually know where this entire TV was made. I think the picture tube says on it somewhere, made in USA, but I can't find anything like on the actual set that says where it's made. Well, there is a Nichicon capacitor back in there. Not sure if you can see that or not. I guess we're not focusing on it. So this may be a Japanese made set. Up here you can see the volume control. How like it looks like just the back of the control, popped off the face. So maybe someone like laid this down on his face and just pushed the control apart or something. I don't know. Hopefully I can just bend those metal tabs back on the front to hold the front back on, and hopefully that'll be good. See if I can take that out somehow. So yeah, the assembly here is kind of like flimsy. You can see that. So they have like this metal frame that comes out and around and up that holds the bottom circuit board, and then this side circuit board is also bolted onto it. But it's pretty flimsy. You can see the whole thing, flexes there. If you look over here, it actually flexes right there. It's like this whole thing lifts up. So it doesn't feel like it's the best built set. I don't know if that's I don't know. Something else that I noticed while looking at this, they have a whole bunch of X-ray warnings all over this thing. They have like a giant paragraph there on the back of the high voltage cage. And it says about like you cannot adjust over 20 kilovolts with zero screen current and all this different stuff. So I'm kind of wondering if maybe this tube, like if they didn't put any lead in this tube to block the X-rays, because usually these colored tubes that operate at high enough voltage to produce X-rays, they put a certain amount of lead in the glass to minimize or block the X-ray radiation coming out of the picture tube. This one, I don't know if I did that or not. I don't know why they would have all the X-ray warnings otherwise, because usually you don't get that many. And like I've never seen this before. They had this giant paragraph on the back of the high voltage cage, and again, this plate used to be here. I took it off, and again they have that there too. they don't adjust above 20 kilovolts. So I don't know. I don't know whether Magnavox was extra proud of it or whether they didn't bother to put any lead extra protection in that tube. And so if you turn it above 20 kilovolts, then you gotta do some extra radiation. I'm not exactly sure. Anyway, the reason why I had that taken off is because I found out that this circuit breaker was toast. That's about as far as I got with this thing. You can, sure if you'll be able to see it there, but that little, this is one terminal. This here is one terminal that comes up and then has that little bend over hook thing there, and then the tab presses against that to make a connection. You can see how the tab is all like, you know, burnt up there. So that's dead. This is a 1.3 amp. I think the back plate said that somewhere. Yeah, 1.3 amp. I couldn't find anything for 1.3 amp. I was able to find, I think, a 1.5 amp, and I also found some 1.5 amp fuses. So I think we'll go with that for now. Hopefully the extra 200 milliamps won't hurt anything. Just for testing, I did jumper this out to see what would happen. Like I did check that it wasn't shorted or anything, and I did jumper it out to see what would happen, and we did get some signs of light from the picture tube. So what I'm going to do today is, just for now, I'll make sure this isn't trying to make contact anymore, and then I'll solder a fuse across here for now, so we can continue testing and see what we can get. And I'll also see if I can take that volume control out of the front up there and see if I can reassemble that, so we'll have a power switch and volume control again, hopefully. So that's what I want to say about this for now. Right, this is a model 2C6226. It doesn't seem to be very common. I couldn't find any other pictures of this, and I was able to find a SAMS folder for it, but it's not an actual folder, it's just the schematic. Let me show you what I have. So you can go on the SAMS PhotoFact website, and they will charge you, I think, $15 for a crappy download of each schematic, or I think like $20 and $25 for a crappy scan of the entire PhotoFact like pamphlet, not the whole set, just for each pamphlet for each set. But if you know the folder number, you can go on eBay and get the entire folder, which contains multiple sets, for about $10 shipped. So for me, it doesn't make any sense why I would ever go to Sam's website and pay for one of their downloads when I can, just for less money, get the entire folder, which has multiple sets in it and is the original high quality print. So you can see this is from, what does it say, October 1973, and what we're interested in is this, the special equipment data. And all that means is Sam's didn't bother to do anything themselves, they just copied and pasted the original service information from the original manufacturer. So this is not a folder. What it is it's just one sheet schematic, special equipment data, and you can see there the numbers. This chassis is, down here it says, alright, so you can see this is chassis number T93616. Now if you look at this page, it says chassis number T936-01 through -10 and 71 through 76. But if you open it up, look at the other side, we've got -11 through -18. So this page, let me back this up a little bit. This page is going to be our set. So all it is this trifold schematic, and right there it says courtesy of the Magnavox company. So Sam's didn't make this, they just copied it from Magnavox. So that's another reason that kind of bothers me, that you go to Sam's website and they want to charge you $15 for a crappy scan of something they didn't even produce themselves back in the day. But anyway, we've got this here. I said it was $10 for the entire folder, so much better deal than Sam's website. So I think what I'll do is I'll solder that fuse in, and we'll go back around to the front and see what this thing does. Well, let's just take a look at this volume control first. You can see you can't see. So I got this out. Let's drop something on the floor. This thing, which I'm assuming went on one of these, hopefully. Maybe that one. Let's go with that. I don't think it'll fit on the other one. Okay, so there's our volume control here, which is bolted on. So there were 4 bolts, 1, 2, 3, 4 that held this in. And then I kind of like wiggled it out. So I'll just take this nut off, which hopefully won't be too hard. Just get it with this thing. One of those, you know, real thin. I'm gonna have to fight with this probably. It's one of those real thin ones that the pliers like to slip off of. I might have to get a wrench. Oh, there it goes. These are those stamped steel, real cheap nuts. This would have come out of here if it hadn't been. Where's that tubing? I'm gonna lose that one. If it hadn't been soldered, something. So there's a capacitor here. Let me see if I can take this out and put it back together. Yeah, so I was able to get that back together. So I took this off and then pushed the control back a little bit. It wouldn't come all the way out because it's got a resistor and capacitor here soldered from this terminal directly to the side here, so it didn't want to come back very far. But I was still able to use some pliers to bend those tabs back around and kind of squash them down. So it seems pretty stable now. Doesn't like wiggle or anything. And the power switch feels pretty nice actually. Volume control doesn't feel like the smoothest. I sprayed some contact cleaner in there. Hopefully it's not like all, you know, scratched and whatever from this hanging loose for who knows how long. So we'll see if that works or not. While I'm here, I'm probably going to spray some cleaner into the tint and the color controls. I think that's what those are. Yeah, color and tint. It's the dual layer. It's actually kind of greasy. I did put a little tiny drop of oil on the sliding part there. I'll probably spray some cleaner into there just to get those clean while we're here, and probably the tuner as well. Actually kind of see the UHF tuner down in there. See the little capacitor, if I tilt this right. There you go. Yeah, the tuning capacitor for the UHF tuner. VHF tuner looks like just a big wafer switch with all the coils. So I'll see if I can get that cleaned up somewhat, then we'll pop this back in, and then we'll see what it does when we have hopefully a working power switch. And before we go any further, something else I also forgot to mention earlier. You can see these resoldered connections down here. Those are the bottom connections for the flyback. So I don't know, you know, whether they had just gotten cold solder and somebody resoldered them, or whether somebody was playing around with the flyback on this thing. Also, when I first opened this up, this was disconnected, and the high voltage cap in here, this open, was also disconnected. And there are a couple screws missing from here. There should be 2 screws here that are missing. So somebody was playing around with the flyback. See, there's the high voltage rectifier tube. You can see down there, there's the flyback itself. It's kind of a funny little thing. It doesn't have the big donut that they usually have. Push that back on there. So, yeah. like I said, I have powered this up with the circuit breaker jumped out, and it did produce high voltage. So hopefully the flyback's okay, but it's something that we'll have to keep in mind if we experience some issues, that the flyback is already suspect just because of that. Whether it was bad and somebody was testing it, or whether they put a new flyback in and then the customer didn't feel like paying for it and never picked it up. I have no idea where this actually came from, like where it was actually found, So, whether it was in a shop or just in somebody's basement and someone was tinkering with it, I have no idea. Like I said, it does produce high voltage, so hopefully it'll be fine. Hopefully someone was just, maybe they were looking for tubes they could scavenge and, pulled this one out and looked at it. Oh, it's not the tube that I want, so they suck it back in. Maybe same thing with that high voltage tube. I don't know. We'll have to see. Anyway, got the front back together. Still have to solder my fuse on here, but I'll do that, and then we'll power this thing up. Alright, so fuse is installed. Before we power it up, I just want to point something out. Before we power it up, I wanted to locate this control. You can see that it says high voltage adjust. So that's what you're supposed to adjust for it to be 20 kilovolts. I just wanted to find that just so I know where it is. In case I think the high voltage is like explosively high or something, I can turn it down. I twiddled with that control a little bit, pretty much left it where it was initially. So I'm just going to try it with that. It's not turned all the way up, but it's not turned all the way down. It's somewhere in the middle. So also, I'm not sure if I mentioned how I found the broken circuit breaker. When I was first playing around with this before I ordered the schematic, I was just doing some basic checks for does it have high voltage, stuff like that, and I found out that there was no B plus getting to the high voltage, the horizontal oscillator circuitry and horizontal output. So of course there's no image on the screen because there was no high voltage. So I found there was no B plus there, and that's why I traced out and found that open circuit breaker, fried circuit breaker. So fuse is installed. Let's plug this thing in. Hopefully nothing will blow up. Oh, and by the way, that control for the high voltage adjust is double stacked with the vertical height control. So you have to get out of this long skinny screwdriver that fits all the way through the center of the vertical height control to adjust the horizontal adjust control. And yeah, maybe not the best idea to use a metal screwdriver, but that's what I have. I don't think there's that much high voltage on that, maybe just like 200 volts or something. So it's not like I'm sticking my screwdriver into like kilovolt regions. Let me see if I can find this plug now. Here it is. This is actually a polarized set. It needs a special, I can't use my regular cheetah cord. I had to take this cheetah cord out of the back of the cabinet to use it because there's one fat pin and one skinny pin on the cheetah cord connection on the back of the chassis. You can see how there's one fat pin and one skinny pin here, so it's a early polarized plug. Actually, is that the Silvertone logo? It's definitely not the Magnavox logo. So this may be a replacement cord already. Anyway, this is off. Yes. Let's plug this in here. And let's see what happens. Oh, we have audio. Actually not bad. Volume control seems to have survived. We have static. On channel 3. Still waiting for high voltage. Hopefully we're going to get some. Hopefully it didn't blow my fuse immediately. Brightness control does nothing. I think we're taking somewhat longer to get high voltage here because it's a tube set. I don't see it working. Yeah, we should have had high voltage by now, I would think. Okay, so let me check and see if it blew my fuse already. Brightness is not doing anything at all now. Nope. Alright, so we do not seem to have high voltage at this point. Yeah, definitely no high voltage. Alright, let me check and see if it blew my fuse. Alright, so it did blow the fuse. I think the reason though is because those, I believe, are fast flow fuses, and that circuit, that fuse also powers the degaussing coil, which when you first turn the set on draws a massive amount of current for the degaussing, and then as it warms up, as the thermistor warms up, it slowly draws less and less and less until it's basically nothing. So my guess is that the inrush of the degaussing coil blew that fast flow fuse. So that's probably why they have a circuit breaker there and not a fuse. I think for right now, what I'm going to do is just jumper out that circuit breaker and hope that nothing blows up. Until I do have another circuit breaker, but I'm not sure if I want to put it in just yet. I think I'll try jumping that out and see what happens, just for fun. And then we'll see if we can get blasted with x-rays. So let's see, I'll just, actually I've unplugged. So let me plug it back in and jumper it out, and then we'll see what happens. Circuit breaker's been jumpered out now, it says plugged back in. See if we can get some x-rays or if we get a fire. So I heard the degauss that time. I'm not sure if it came through on the camera. Still had static. I don't see my jumper wire glowing red hot yet. I don't see the horizontal output tube red plating yet. Oh, I think I hear it running. That characteristic high squeal. And there we have high voltage. It's really screwed up. Let's see, that's brightness. Got brightness, we've got vertical, somewhat better. I can probably adjust that vertical centering control. That was this one. Doing something? Not really. I think that was it. So vertical's kind of screwed up. I'm not sure what's the deal with this. I've got a blue line across the bottom, then a red line, then like a yellow line. And the raster is actually changing colors. That's interesting. The raster is changing colors. Started out yellow, and now it looks a little bit reddish. This is adjusting color. Yeah, so the raster is changing colors. This is tint. Ooh, there's some static there. Yeah, see it changed colors again. I don't know if it's going to come through on the camera because the camera probably is like auto white balance, whatever. But yeah, the raster is changing colors. So there's definitely some static there. So less static there and not any static on the screen. So there's definitely static there. So that's UHF, of course. Why does the UHF tuner work, not the VHF tuner? Nobody can't use UHF anymore. Only use channel 3 and channel 4. So maybe we need to get some more cleaner into that tuner there. I have audio static though, so not sure why. Yeah, so you just changed it look kind of white and then it changed kind of yellow. It's weird. I don't know what's up with that. So yeah, we do have high voltage, we do have a raster, we have a color changing raster. Next question is, are we getting blasted with X-rays? Turn brightness up, turn brightness down. So I need to, ooh, that's cool. So I need to take a look at those vertical controls and see vertical linearity. Well, I was adjusting vertical height before, that's why. So, let's see, this is vertical height. That doesn't seem to do a whole lot there. You've got this guy, this one is completely floating, that's cool. Oh, there it goes. That one seems to do absolutely nothing. And there's another one in the middle of that. My skinny screwdriver here. I'm going to try that one out. What does this do? That one doesn't do either. So there's something screwed up with the vertical that it won't fill out to the bottom. So we have to look into the vertical. Should probably get a signal source on this just to see if we can like tune in anything. Yeah, like vertical centering, it almost fills out there, but vertical centering seemed to have like no effect. So might look into trying to clean some of those vertical adjustments on the back. But yeah, it does seem to work. Nothing seems at least completely shorted, nothing blew up, so that's a good sign. So I might try installing that circuit breaker next, just for fun. Let me show you what I got. So the circuit breakers I was able to find were this one, which is a new one, I think it's new. But this is 1.4 amps, rated draw, and then 2.0 amp blow. I think that's going to be too high. The original was 1.3 amp blow. I was also able to find this, which is an old one, new old stock, 1 amp hold, 1.5 amp flow. So this is probably what I'm going to go with. I think it should mount in the same way as the one that fired up. It is rated 200 milliamps higher than the original one. The original was 1.3, but this is, the closest I could find. I couldn't find anything 1.3. I don't even think I could find any 1.3 amp fuses. Or maybe if I did, they were probably like something I'd have to install a fuse holder for. I'd rather not hack this up if I don't have to. So I'm probably going to go with this and see how this goes. I think that this 1.0 amp hold should be fine. I don't know what the rated hold current of the original one was. It just says 1.3. So I don't know whether that was like 1.3 carry and 1.3 trip or what. But I think it should probably be fine because this is just going to see, this is only going to see peak current when you first turn it on and the degaussing is active. Once the degaussing dies off, it's going to be much less than that. So if this is drawing under 1.3 with the degaussing on, then hopefully it should be fine with this 1.0 amp hold. We'll see. If it fires this, then I'll have to find something else. But let's sure if you can see it there. Something about over 40 years, and this thing's probably 40 years old, so it might be 80 years now. Anyway, so I might pop that in, clean those vertical controls, and see where we go from there. So kind of, I don't know, I hope I showed up in the camera how this was like changing colors. Like it would start out almost bluish and then change kind of yellow and then like get kind of white and then go back to yellow again. It's really weird. I don't know what's causing that. So that's going to be fun. Like I said, I think all the color demodulation in this TV is tube. So I don't think they use any wax capacitors though. I think they're all those like the plastic films. So hopefully you shouldn't have to worry about too many bad capacitors. But anyway, let me see if we can fix our vertical stuff. So if I'm going to be able to capture this as well as I want on camera, I decided to do some voltage checks just for sanity. I think those controls, I haven't fired it up again yet to see if that made any difference, but I just want to do just some quick checks. It looks like the vertical gets some of its supply from the boost source. So I want to check that. According to the schematic, that should be 550 volts on the boost source. So that comes off right here, which you can't even see. This wire here comes off the boost source. So we're going to check that. One side of this high voltage adjust, this one here, should be 200 volts, and the other side should be a resistor to ground. So I just want to make sure that this is, properly adjusting and that it's not like, running wide open the whole time. Just before we go any further, just for, I don't want to be microwaved. So we'll check that. I guess we'll just start with that for now. Maybe check the B+2. I noticed that some of these are labeled here. This says plus 260 volts. This says negative 400 volt pulse. That's interesting. What they need negative 400 volt pulses for. So anyway, I want to start at least checking the boost source and checking that this high voltage control is actually, adjusting like it's supposed to. So we'll plug this in. I have turned the high voltage control down almost at its minimum. It was a bit above halfway before. We'll plug this in. Our circuit breaker is still jumped out. Turn this on. I can. So let's see what boost source wouldn't have anything yet. Actually, let's put this on voltage mode before I blow something up here. Oh, it's rising. That's a bit high. That's rather high. There it goes. Well, no, 698 volts. That should only be 550 volts according to the routing off the schematic anyway. That's interesting. I don't see a label on the board what it's supposed to be. Slipped off the terminal there. 700 volts. Let's see, on this side we should have 200 volts, which we do. That's Xeno regulated. In the middle we have 118. Yeah, that changes it. Let's go back here and see if it does anything to this. That's 704. Oh yeah, it turns it up. Now it won't go down below 700. Okay. Let me turn this off then. Something is weird. Okay, so we're good. Let's kick the camera there. I'm gonna look into the horizontal circuit some more. See if I can get good test points in here to check voltages, because according to the schematic, which if we go over here, I have the schematic laid out over here, so hopefully it doesn't get as dirty. So this line here is labeled boost source right there, and that comes down and also goes over through a J7 up to here, which is the screen controls. And if you follow this line, see they have a spark gap there, and if you follow this line down straight out, it's plus 550. And that should be directly connected to the boost source. And what we're measuring there is like 700. So that's like 150 volts too high. So that's got to be checked out. And the high voltage adjust only turns it up. Like with the high voltage adjust all the way down, it's too high. So I'm going to have to take a look into that. And if you look here, boost source goes over and goes up through a resistor, and then through the height control, and then up, and then the linearity control. Am I seeing the right thing? it goes up and then over and is connected to the vertical tube. It's not the B plus supply for the vertical tube. And it looks like it also, let's see here, it's also connected to the grid, is that right? Through this resistor, it's connected, so it looks like it's capacitively coupling, well, there's a capacitor there, 0.01, the linearity control, up to there. I'm gonna take a closer look at this. The screen is controlled by that. There's a resistor and then it goes to the grid, so yeah. I'm gonna have to take a look at, see if I can figure out why that boost voltage is so high, because that, since it is going up to the vertical circuit, that being too high, may affect the vertical as well, why we can't get a full raster. So, actually you can see on the bottom here, this is the dynamic conversion adjustment. They actually have pictures of what each one does. So you can see bottom vertical red green and top vertical red green. Bottom horizontal red green, top horizontal red green, bottom horizontal blue, top horizontal blue. So yeah, I guess it's just, it's interesting. Anyway, hopefully won't have to play with those, but if we do, we're whiles away from doing that. Actually, looks like it's missing a couple of knobs. Not sure how you intended to do that, because with the TV like this, laid on its face, you can't see the screen, so you can't adjust these that way. I guess you're supposed to lay it up on its side or something, I don't know. That's kind of weird. Anyway, definitely have issues with too much boost, which may mean also too much high voltage. So let's check into that. So you can see the high voltage adjust here. One side goes to a 68K to ground. So just for experimentation, I jumpered in another 68K right across it, so I'll half the value. Be what, like 34K? Just to see if that makes any difference. And I'm turning this kind of up towards the middle because that should bring the high voltage down more on the low end. We'll see. I don't want to run this for long because basically that's going to be doubling the current through that pot. It's basically acting like it was a resistor divider. Because one side is 200, one side of that pot is 200, and the other side goes to that 68K resistor. And if you turn this down all the way, before you were getting around 100 volts, which would be, what you'd expect about that for a resistor divider, because it's a 68K resistor connected in series with 50K pots. So, almost half the voltage would be dropped across each. A little bit more across the resistor because it's a higher value. So, anyway, turn this up towards the middle a little bit. Let's just see what this does to our boost voltage if it gets it down somewhat. I don't think this is the problem because I checked that resistor and it measures okay. And like I said, that voltage is kind of what you'd expect for a resistor divider. So I think that this pot and that resistor are working as expected, just somehow they're not having the desired effect. So what I want to do as an experiment is see if I drop that, high voltage control voltage, I guess you'd call it, a little bit lower, if it has the effect of lowering the high voltage even more. So we'll see. You can see the meter, so let's go here, wait for the oscillator to start. It's rising, it's rising. I hear the oscillator now. It's still rising. Slipped off again. So now I turn the control all the way down, and it's still at 629, so that's still too high. According to the schematic, let me turn this off. So it did have the effect I was expecting, where it allowed me to adjust the high voltage lower, It was at 700 minimum before. Now we got it down to like, what was that, 630 or something. So only about, what, 170 volt, no, 70 volts, only 70 volts down, but we need to go like 150 volts down. So yeah, something's definitely screwed up here. That's way too high. And it's probably also means that the high voltage is too high. We're getting blasted with x-rays this whole time. So that's fun. So yeah, let me do some poking in this horizontal oscillator output circuit and see if I can find anything that looks like it would be causing that. Yeah, something funny I kind of noticed here. Let's see, right here, they've labeled T101. This is the bottom side of the flyback. And it almost looks like they even put like a little tiny picture of the flyback there in that square, which you can't see because the wire's in the way. But they have like, the big coils down there with the frame coming out of it. So it's kind of funny, I thought. Anyway, also something to note is almost all of the solder joints on the back of the circuit board look like they're cracked. You can see someone already reflowed these two. Looks like they tried to reflow that one and got a cold solder joint. So those will have to be also looked at. Anyway, so what we got to look into now is way too high focus voltage, which probably means also way too high voltage. So let me see if I can figure out what's going on there. Alright, so looking at this high voltage adjustment circuit here, you can see we've got quite a few resistors in here. We got a 270K, 470K, 100K. This 68K we already checked and we know that that's right around value. But checking these other ones, let's go over here to the actual set up our meter. It's readable, and start checking these. Okay, so the first one is the 470K is R124, and Magnavox is nice enough to label the bottom of the board, so I can go right here and I can see R124 is supposed to be 470K, so we'll check that, and we get 557, so that one's high. We can also check what the other one is. R123 is supposed to be 270K. R123 is right here. That is also high. It's supposed to be 270K, it's 321. We can also check that 100K, which is R125. Let's see, where's that one? R125 looks to be right about here. And that one's a little bit high, but not too bad. I think I'm going to change all three of those resistors and see what difference that makes. And you can see right here, they were nice enough to label, so you can see they even point out like which pins it goes to. So like R123 goes from this pin to that pin, or 124 from that pin to that pin. So pretty nice of them to do that. And even on some of the tubes here, you can see like this is the damper tube right here, this V104. They even labeled that on the bottom that inside the tube, this pin and this pin are connected together. You can see they drew a little connection there. So definitely a nice job labeling the circuit board. Everything is pretty clear. You can see for like the coil, they even drew like the outline of the coil on the bottom of the board. Same thing for like these, this little diode pair here, selenium rectifier. They show like which pin is which and how they're connected. So that's pretty nice. All this labeling they've done. Same thing for like the pots. Like this is one of those double-decker pots, so they show like, they even say like this is the height control in the front and HV adjust in the back, and that they're two pots connected together. So yeah, definitely a pretty nice job labeling this board. And the top side also has the same labels too. So we go over here. Not sure if you'll be able. To see because it's kind of dark, but down there they got all the same labels for what each component is and all that kind of stuff. So yeah, it's definitely pretty cool that they went out of the way to like extra label everything. It's pretty nice. Anyway, let me change those resistors and we'll fire this thing back up and see if our boost voltage is any more sane, or these can be adjusted properly. Oh, so I'm going to replace the 470K and the 100K because I don't actually have a 270K. I only have a 220K. And with the 470K out, I think the 220K was measuring about, it was like 350 or something like that. Was it 320? I don't know. Anyway, it went up a little bit because there must have been like some leakage like back to the circuit that reduced the resistance. So it did go up a little bit in resistance. But I think whatever I measured was about the same like percentage out as a 220K would be. So like putting a 220K in place of that high 270 wouldn't actually get the value any closer to what it's supposed to be. I think is what I was measuring the actual like variance. So I have that in for now. We'll see what we get with the 470 and the 100K replaced. I've got my meter hooked back up on the boost source. We can measure that. You can see we're still in the safety mode here with the circuit breaker jumped out. Still have to install the new circuit breaker yet. Let's get this thing plugged in here. So we're plugged in. Make sure these aren't going to short out because there could be like 500 to 700 volts on those wires. And we'll turn this on and see what we get. So you can see the meter there. Also see my wires in case there's any fire that happens. Turn this on. We're still way too high. 720. Yeah. Something is still definitely wrong here. Alright, so that is still way too high for that boost volt. It's only supposed to be like 500 volts. 550 volts or something. So something is still definitely wrong in that circuit. So let me look at the schematic here again and see if I can identify anything else that I think might be causing that. I don't think that one resistor being out of tolerance that much would really have that much effect on this. And when they're all a little bit out of tolerance, things can be like really whacked out. But one resistor being a little bit out of tolerance, I don't think would cause this much of an effect. So I hope this only didn't put like the wrong flyback in here or something. Like I showed before, there is like definitely work like someone was playing around with the flyback here. So I hope this is the right flyback and it's not like some whacked out one that's generating way too much voltage or something. But let me go through the schematic and see if I can identify some other parts to test, and we'll go from there. Alright, so I think I found my mistake. I was looking at this right here, 550 volts, and thinking that was directly connected to the boost source. But actually, it goes through this resistor here, 470K. So this 550 here is not the appropriate boost voltage. This is dropped by this 470K resistor. Now I checked this voltage with it running, and by adjusting the high voltage control, I can get it to go from 500 at the low end to about 545-ish at the high end. But if we check this resistor, which we can do right here, is this one right here, R134, from this boost source terminal up to that point right there. Let me flip this up here. visible, and if we, the wire's out of the way, if we check that, we can see it is measuring almost 600K, so that one's way high. So that would probably be the reason why I can't adjust the high voltage control to get 550 volts at the focus source, because that resistor is high. So let me change that, and hopefully we'll get an accurate reading at the focus voltage of what the boost, like proportional to the boost, and we can set our focus, we can adjust the high voltage control so that the focus voltage is 550, and then hopefully everything else should be in alignment with that. So I'll change that resistor and then see what we get for our voltage readings. So there's the resistor down there, that little one hiding behind this one standing up right back there, that's it. It was way more annoying than I thought because it's inside the high voltage cage. So to get to it, you have to take the whole high voltage cage off, which is actually kind of annoying. But at least now you can see the flyback. It's kind of a weird looking flyback too. You can see the primary and secondary almost the same size. It doesn't have like a giant donut for the secondary or anything. Kind of a weird thing. But anyway, to get this off, you have to unmount these two screws here that are down here, screws into the side of the frame. Then it kind of unlatches from the other side. Then you have to pop off all the connectors on this side. Then you have to unmount the high voltage rectifier socket on the inside because the filament wires aren't long enough for you to lift this off any amount. Then you have to unsolder this wire from this fuse over here because that's too short. It comes out of this transformer, so it's too short to lift this up any amount. And to take the wire out of this slot here for the horizontal output tube, so kind of annoying. Let me change that resistor. Now, I may have noticed I did change the, actually you didn't notice because you can't see it, I did change the horizontal output tube because when I was fiddling around with this I managed to pull the plate cap off the original one, so I got a new one to put in here. This is a 22KM6, and these tubes were only about like $4 on eBay, so not a big deal. Anyway, let me change that resistor and we'll shove all this stuff back together and see what our voltages are. Yeah, so now with that resistor replaced, you can see I can adjust the voltage down to around 515 and all the way up past 550. This is the focus voltage, so bring this back down to around, I'll leave it around there I think, just on the little bit under just to be safe. So hopefully that will be sufficient there. Let me check now what our boost voltage is actually right here. 769. Okay, so across that 470K resistor, then you're dropping down to 543. Okay, so let's flip this thing back up, I think, and we'll take a look at what our vertical looks like now that we've twiddled with the high voltage controls and everything, and just see if our vertical looks any better. Alright, so now let's see what our vertical does. So that sound. Dirt on the screen now. Have to clean it off. Okay, so vertical is still super whacked out. Let's try. So that's adjusting vertical hold front. Why it's jumping like that? It's weird. Can adjust some stuff on the back. Let's see, this would be vertical linearity, I think. It doesn't seem to do anything really. So little screwdriver go. So let's try to adjust vertical height. This. So a little, I think that's height. Let's see which is which now. That's vertical centering. Vertical height is over here. Just vertical height. So that's turned all the way one way. That's vertical centering. So we can't get it to go down all the way. If I turn height. So that's height turned all the way to one extreme. That's height turned all the way to the other extreme. So it doesn't seem to actually be adjusting the height. It looks like it just causes some fold over at the bottom. I'm not sure if it deals with this blue line either. It's super weird. Not really getting much for snow. Might be kind of there, but there's some. Here you can see the snow. It's like either focus or convergence or something seems kind of whacked out. Let's tint. Shouldn't really have any effect because there's no color signal. Change it a little bit. Let's color. Let's color all the way down. Color all the way up. So yeah, something is weird with convergence or something. Let's see what we can do here. So I might have to just start checking some voltages in the vertical circuit, because none of these adjustments really seem to be doing a whole lot. This tuner doesn't seem to want to pick up a whole lot either. So that's UHF. UHF, you get plenty of snow. Channel 2, channel 3. There's something there. What's that? That's channel 8. What how good that does. I'll try hooking up a signal source to this just to see if we can figure out, what the issue actually is. But I did clean this tuner. UHF plenty of snow. Channel 2 basically none. Channel 3 hardly any. So do we have a horizontal hold on here or something? It's on a frequency. It's this guy here. Sure, that's gonna. I don't know why I'm playing with that because we don't have a signal to match against, but channel 3, channel 2, not much. Channel 5, not much. Channel 8 gets snow, channel 9 gets some, channel 10, 11 gets this weird pattern, 12, 13, UHF gets snow, back again. Do that like sound. That's something back here. So you can hear like a low level hum. Try adjusting the vertical. Almost like it's like whining. Yeah, that is the vertical. That's me playing with the vertical hold control, you can hear it. And now when I turn the vertical hold control all the way one direction, you can see it almost fills out, but you can tell by the flickering that frequency is way too low. Like if you try to put a picture of this, it'd be just rolling like mad because that frequency is way too low. So yeah, let me do some investigating into the vertical circuit. I'm going to check a bunch of resistors in there, since we already had some high resistors in the horizontal circuit. What I don't like is they don't give you a lot of voltage. They don't give you a lot of voltage measurements for things I would like to check. So if we go over here, you can see the vertical output tube is this one. And that's fed off this boost source through a resistor. I've already checked this resistor, it measures okay. 1.8 meg, that was also inside the high voltage cage, so while I was in there I measured that. That looks okay. Then it goes through the vertical height control, and then up and over to the linearity control, and then also goes to the suppressor grid of the vertical output tube, and then it also goes to another resistor, and then up to here, which is connected through a resistor to the grid of the vertical output tube. So this boost voltage has a lot of interaction with the vertical output tube, but they don't really give you any voltage measurements for this particular line. Like it doesn't tell you what the voltage should be here on the, is that the screen grid or the suppressor grid? So it would be the suppressor grid. Yeah, 140 volts on the screen grid, and then nothing, who knows what the suppressor grid's supposed to be. They do give us -9 volts for the control grid. They don't give us any voltage measurement for the cathode. Let's see, what does the cathode go to? So the cathode goes to, pin 9 is the cathode, goes down to here, which goes through this normal service switch, and then through a resistor to ground. So we've got a 471 watt resistor to ground. So, if that's gone high, it could be, reducing the voltage drop across this tube, which, may affect the performance. This is a lower value though, so I'm not too sure about that, but we'll check it. Got this 1.5 meg, we'll check that. Got a 1K there. I don't think there's really any paper capacitors in this set. They all seem to be the plastic film ones, so I don't really think this is going to be a capacitor issue. Yeah, let's see. This cathode also has a feedback capacitor from here, from the oscillator. So they got a solid state oscillator, transistor oscillator, and then a tube output, which is pretty common. Usually the high power stuff like vertical output remain a tube longer than the low power stuff like the oscillator. I think it's kind of interesting there is that all the color processing is tube. So like the video output is a tube, and then the burst amp is a tube, the color oscillator is a tube, RY DMOD is a tube, same with BY DMOD, and then GY amp is a tube. So like all the color processing is all tube. I thought some of this would have been solid state, but it's not. Of course, it was, I don't know. I'm not exactly sure like what was normal. I don't work on a lot of these sets, so I'm not sure what other manufacturers did for their color circuits. But yeah, I kind of thought that this would have been solid state in this set. I didn't think that color demodulation was like a high power item that needed to remain as tube. But anyway, right now we're just focused on this, so let's stop getting distracted here. So we're going to start checking some of these resistors in here. I wish they would give me a voltage for the cathode and the suppressor grid, but they don't. So I can at least check the grid voltage here. And they're giving a plate voltage 280, but I'm not suspicious of that because I think that comes from the regular B+. Yeah, power supply in through the vertical output transformer and then right into that tube. So yeah, I'm not suspicious of that one, but just because we adjusted this focus voltage to 550 volts doesn't guarantee that the boost has the right voltage, and I have no idea what the boost voltage is supposed to be. So anyway, let me check some of these resistors and see where we go from there. Alright, so I was complaining that there was no voltage measurements for the cathode or the suppressor grid for the vertical output tube. But if you look at the other side, which is schematics for the similar but other chassis, you can see that here they do give voltages for those values. So the cathode here is supposed to be 12.5 volts, and they've got the suppressor grid labeled at, it's like a negative 9.2. There's a negative there. Where am I pointing this at? Yeah, it looks like a negative, either 9.2 or negative 9.2. Can't really tell if that's part of the hour or not. Either way, that's at least gets us somewhere, something we can check. And even though these are different sets, this circuit seems to be pretty much the same. And it's a really weird vertical circuit, in my opinion, the way that they've done this. You can see what they have here. Go back to the set which we have, and you'll see that it's pretty much the same as. You can see what they've done here is the boost source down here. Some of this stuff. So they've got the boost source down here, going up here, up through a 1.8 meg resistor, and then through the height control, which basically just varies the resistance in line here. So the height control will either add or reduce, increase or decrease resistance from the boost source up through here. Then it goes up, and then it goes to the linearity control, which the other side of which is connected to a capacitor to the 280 volt B+. It then also goes directly into the suppressor grid, and it then goes to a 1.5 mega ohm resistor to the signal line here, which has a 0.047 connected to the collector circuit of the vertical oscillator, and a 1K resistor connected to the control grid of the vertical output tube. And then it goes down into the service switch, the normal service switch. And this actually has 3 positions. It has normal, horizontal, and service. Not quite sure what the point of the horizontal one is. Usually the normal service, so like when you put it in service mode, it'll shut down the vertical oscillator, so you just get one line on the screen for help setting up convergence and stuff. But anyway, so that's why this switch is in this circuit. So in the normal mode, when the vertical oscillator is engaged, that's all it does. It goes down to the switch, and it's not actually connected to anything in the normal service switch during normal mode. So yeah, so basically, I don't know why they've done this, but they've got the 700 volt, like 600 or 700 volt boost that they're trying to drop all the way down to, according to the other schematic, like either 9 or negative 9 volts to go into this suppressor grid and provide some bias for the control grid. I have no idea why they did that. Usually the boost voltage is used to power the plate circuit of the vertical output tube. So I have no idea why it just seems very strange to me that they would do that. Anyway, you can see on the other side, we've got basically the same thing, just drawn a little bit different. So you can see the boost source here comes up, it goes through that same 1.8 mega ohm resistor, over here through the height control again, same thing. Then it goes up, and then then it branches off to the suppressor grid. It also goes over here through the same 1.5 mega ohm to the control grid circuit, and then up to the normal service switch where it's not connected to anything again. And they've also again got the linearity control connected to a capacitor up to the B+. They've got the same 0.047 coupling back to the oscillator collector circuit, and they've got the same 1K ohm going into the screen grid, or the control grid rather. And then the cathode circuit, on this one you can see the cathode is measured at 12.5 volts. It comes down, it has a 0.047 back to the oscillator collector circuit. It has this line going over to a resistor and capacitor pair going to the vertical convergence assembly. It also has this 470 ohm 1 watt resistor to ground. And then it also goes up into some stuff in the normal service switch. But in normal mode, that's basically how it's connected. So that cathode goes up to the normal service switch, and in the normal mode you can see pins 5 and 6 are connected, and all of that, it looks like all of that does is connected over here to this resistor, though they're showing it's already connected there, so I'm not sure that's actually doing anything. But anyway, if we look at our set, again, basically the same thing. The cathode goes down, it goes over, it has that same 0.047 back to the oscillator collector circuit, goes through the normal service switch over to that 470 ohm 1 watt to ground, and then also again over to the same resistor capacitor pair into the vertical convergence assembly. So I'm going to assume that those voltages would be the same for this set because the circuit's the same. I can't really see any differences in the circuit. There's a little bit of difference in how the normal service switch is set up, but it looks like in the normal mode everything's exactly the same. At least it looks that way to me. So I'm going to assume those voltages are correct with respect for this set. And this says -9 here on the control grid, and it's the same tube too. They're both 17JQ6 is the same tube. Yeah, just want to double check. The same tube, 17JQ6, and this one also has -9 here. -9 on the control grid, 280 volts on the plate, and 140 volts on the screen grid. And then in our set, we have the same 140 volts on the screen grid, 280 volts on the plate, and -9 volts on the control grid. So I'm going to go by those other two voltages, the 12 volts on the cathode, and either 9 or -9 on the suppressor grid. Now there's something also interesting going on here, because this is not just a suppressor grid here. If you look closely, if I can get this in frame, you can see that there's actually a diode in that tube. You can see that the line here from the suppressor grid actually goes down, and there's a little diode right there. You kind of see a little tiny diode plate right next to the cathode. So what the point of that is, I have absolutely no idea. And I'm not exactly sure how this is supposed to work, because in order for you to have voltage drop across these two resistors, the 1.8 meg resistor and the height control, you have to have some current flowing through here. Like if this line was completely open, like had no current at all, then this would also be at 700 volts. So if they're expecting either 9 or -9 volts here on that suppressor grid, there has to be some current flow through here to cause that huge voltage drop, basically dropping 700 volts. I don't know why they've done this way. It seems very strange to me. But I can't really see where exactly that current is supposed to go. Like, yeah, some of it would go through that diode. But if this cathode is supposed to be 12 volts, and this line is supposed to be either 9 or -9, the diode alone wouldn't account for that, because diodes only flow current, in one direction. So, you're only going to flow current through that diode as long as this voltage is above the forward voltage drop of the diode. So, for a tube, maybe that's, I don't know what it would be, a couple volts probably, maybe more. So if this is at 12 volts, then probably the most that diode could, drop to and still conduct would be, maybe 15, 20 or so volts or more, depending on the diode characteristics. I don't actually know what the characteristics of the diode are, but regardless, that diode would never conduct if the plate voltage of the diode is less than 12 volts. But they're expecting this to be either 9 or -9. So there has to be some current flow somewhere else that would cause that. And there really shouldn't be any current flow through the tube from the suppressor grid, because if this is -9 volts, that voltage is below the cathode, so there wouldn't be any current flowing from there to the cathode. It's the same idea as the diode. And I don't really see anything else here that would flow current. This is 280 volts up here, and it's capacitor isolated. It goes over here through a resistor to here, but then this is capacitor isolated from here, and this directly connected, well, through resistors to the control grid, but the control grid really shouldn't flow any current, again, because it's negative with respect to the cathode. This is negative 9 volts, so no current is going to flow from the control grid to the cathode. And then it just goes down to a dead end here at the normal surface switch. So unless I'm missing something obvious, I'm not 100% sure how that circuit is supposed to work, like what's supposed to draw the voltage down that far with respect to this 700 volts up here. So yeah, this is just a really weird circuit in my opinion. I can't understand why they would try to drop 700 volts from the boost source to get the grid and suppressor grid bias for this tube. That's very strange to me. Usually this should be just have like a resistor, 100K or something resistor to ground, and this screen or suppressor grid should be grounded, but instead they've done this really weird setup here. So yeah, I don't really know. Same thing too with the horizontal output circuit. The B plus for this horizontal output circuit actually flows through the vertical output transformer. So you can see we've got 280 volts coming in here that goes to the vertical centering control. Now I'm taking a look at this circuit too because I don't think our vertical centering control is letting us center properly. Even at one extreme, I can't get the centering to go down far enough, I think. So that's going to take some looking into, but same thing here. So we've got the 280 volts coming in, and then we've got the vertical centering control across here, and it also goes up to this coil of the transformer, which is connected to this coil of the transformer, which is connected to the other side of the vertical centering control, which then goes down here through this jumper in the yoke socket connector, and then over here and is the B plus for the damper tube. So basically the B plus current for the horizontal output circuit has to flow, like some of it's going to flow through this vertical centering control, and the rest of it's going to flow up through this coil, down through this coil, and let's see, is that the right coil? Yeah. No. Wait. Yeah, down up through this coil, down through this coil, and then over to the horizontal output circuit. So you can see that, yeah. Again, that seems strange to me. Or why they've done that, I don't really know. You see this top side of the coil is what goes over to the vertical yoke, and then the center, the wiper of the vertical centering control is what goes over to the other side of the vertical yoke. So what the centering control is going to do is it's going to change the bias voltage from 280 volts down to whatever this side would be, connected directly to the horizontal B plus. Well, connected directly to the damper tube at least. So basically all that's going to do is vary the DC current through the vertical coils, which varying that DC current is going to give it the offset of the centering. So if you have a DC current flowing through these coils at all times, that's going to basically create a baseline magnetic field, which will affect the baseline deflection and give you the centering. So more current means more magnetic field, means more offset of the, whatever you want to call the natural deflection. And then of course the sweep is then added to that to deflect it, either positive or negative from that baseline that you're setting with this control. But again, why this is in the B plus supply for the horizontal circuit, I find that rather strange. I don't know if it has something to do with the blanking or what, but it seems strange to me. Anyway, let's get on checking these voltages. So we'll check the 12 volts, like 12.6 or something. Let's see what it was. It was 12.5 and either 9.2 or negative 9.2. So we'll fire this thing back up, check those voltages, and see what they are. Get my thing set up here. So we'll plug this thing in. We'll turn it on. And so we can check the cathode is pin 9. Of course, it's not warmed up yet, but let's see, cathode of the pentode. Let's see, what's it at right now? Right now it's at 75 volts. That's way high. See what happens if the tube warms up. Dropped somewhat. No, not a whole lot. So we have high voltage now, right? What's our boost source at? Boost source is at 739. And this is at 61. So that's supposed to be 12? This is pin 9, right? Pin 9 is supposed to be 12. And we are at 61. So either that tube is like not flowing any current, or resistor is open, or something weird. Let's check. Also got some whining. I think that's out of the vertical something. Not quite sure what that's about. Yeah, that's vertical. If I change the vertical hold control, the whining stops. Or it changes tone at least. So I changed that. Let's see, did this change when I changed that? 59, it changed somewhat. Still way too high though. Let's check G3. The suppressor grid is pin 6. This one here is supposed to be either 9 or negative 9. We're getting 55. So we're obviously not dropping enough over that, obviously not dropping enough over that height control. And the height control is all the way down, I think. So what happens if I try to change it? Let's see, it's this one here. Yeah, it just goes up. So that's the lowest it can go. We can try, see, what's G2, the screen grid? 156, that's going to be 140, so it's a little bit high, not tremendously high. G1, it's supposed to be negative 9, and it's 53, that's lovely. So we got 53 there, we've got 59 there, so the control grid is actually somewhat negative with respect to the cathode. So that's somewhat of a good sign. Is that too unpleasing? No, it's not. It's not great though. I don't see it wet plating. So let's see. So the boost source is here. That is 744 volts. Then we've got, I think this is that 1.8 meg resistor. The other side of that, we've got 475 volts. And then that goes to here, so this should be 475 volts, which it is. And then dropping across the height control should bring us down to our 55 volts. So yeah, it's just not dropping enough. So I'm not, like I said, I'm not quite sure what is supposed to provide the load to drop that. We can check, maybe we can check for leaky capacitors or something. We can check on the other side of C135 and C133. See if I can find those real quick. So C133 is here. And let's see, this side is our 59 volts. So that would be the cathode. I believe that's connected to the cathode. The other side is 4 volts. So yeah, that's definitely not causing our voltage increase. So that 4 volts there is the collector circuit. That doesn't make sense. So, see right here, where am I? Not showing the right thing. Here we go. Right here is at C133. So this side is the cathode side, which is the 59 volts or whatever. This other side you can see is the collector circuit of the vertical oscillator transistor, which was measuring 4 volts, but down here it says 15 volts. So that's whacked out. I wonder if that oscillator is not oscillating like with enough power or something to provide the negative voltage that we need. Let's see if we can, so that capacitor should go to R137. So R137 is here. So on this side we've got our 4 volts, and on this side we've got also 4 volts. So that's supposed to be 15 volts. That's interesting. Let's see, what supply is that? We can check our transistor bias. So the emitter is grounded. Let's see, the emitter is grounded, so that should be 0. That's correct. The collector is our 4 volts, and the base is negative 1.29 millivolts. It's supposed to be negative 0.6, so that's a little bit low. Well, I should say a little bit high. It's not as negative as it should be. I have to check where that comes from. Let's see. There's a 10 meg 1 watt resistor that provides. What in the world? So let me go back to the set that we're working on, see if that's the same. Yeah, okay, so 280 volts through a 10 meg resistor. I wonder if that 10 meg resistor is high. I don't know if I have a replacement for that. Okay, so if I can find that. Let me just show what I'm talking about here. So let's see where we are. So this is the vertical oscillator transistor. Right here it says 15 volts. We have around 4 volts. And that supply comes through this, is that 820? It's an 820 resistor. We also have 4 volts here above that resistor. And that's supplied via a 10 meg resistor from the 280 volt source for some reason. So I believe our 280 volt source is fine. We can probably check it if we can find that resistor, which is 135. So that should be, let's see, we had found that first resistor, right? R137, R135. So on this side of R135 we have 4 volts, and on this side of R135 we have 751. I thought that went to the 280 volt source. W7B. W7A is the boost source. This is interesting. So I'm misreading this. So this right here, let's see, where am I pointing it in front here? This right here says W2A 280 volts, but then this says W7B, and then the trail ends there. W7B, I'm not sure where that goes, but W7A is the boost source. I don't see one for W7B, which is interesting. I just don't see it at all. But definitely that's going to the boost source. So actually I can see that right here, right? So this is that resistor. W7B says boost, and it is boost, and there's a wire going right from that point right on over to the boost source. So we're definitely attempted to boost. Why would they have a 10 meg resistor dropping the 750 volt boost source down to 15 volts instead of having a much lower value resistor dropping the 280 volts down to 15 volts? I have no idea. This design is just weird. Anyway, my bet is that resistor is high. If that resistor is high or the transistor is biased on too hard. Take a look at where the transistor bias comes from. Comes from the vertical hold control, it looks like. So if we go back on the base here, it's at negative, if I adjust this, so right there, that's where it's supposed to be, negative 0.6. So that would actually be okay, negative 0.6, it works. And it's probably, the frequency is probably whacked out because this voltage is too low. Now it's at 9, so it's closer, but it's still not 15. Let's see, did that change? What did that do for our G1 voltage here? 45. That's lower too, actually, isn't it? What about the cathode voltage? Cathode voltage, it's freaking out. Let me get a good connection here. 50. So that dropped somewhat too. So I wonder if that's the issue here. Go back on collector. See if I can get this up to 15. 10, 12. No, it only goes up to 12. Now when that's at 12, this is at 45. So still not correct. And G1 is at 37. So still not correct. See, how much voltage drop is there actually across this resistor? So this resistor, one side is 12.05, the other side is 12.08. So very little voltage drop across that. Most of the voltage drop is across that 10 meg one. Let me see if I can figure something out for that. I don't think I have any 10 meg resistors. Certainly not in that wattage. So 1 watt, 10 meg at 1 watt. It's a very strange part. Anyway, let me see if I can figure something out. Maybe I'll just use like two 4.7s for now or something. Just see if we can get some voltages on that transistor and on that tube that are closer to what the schematic calls for. So let me try and substitute that resistor and also check the other resistor there, which is an 820 ohm. I doubt that drifted much, but we'll check it anyway. And also check the resistors in the vertical hold circuit. So you can see down here we've got a 5.6K, 5.6K, and then to the vertical hold control here. So I'll check those as well. This goes back to vertical sync, which is supposed to be 5 volts. Oh, it's capacitor isolated, so no, that's fine. There's a capacitor there, so that voltage is fine to stand on its own. Okay, so actually let's check now, see what our base voltage is at. So now the base voltage is almost negative 1 volt, so yeah, that's not correct. Oh. Can you hear that vertical output transformer? It's like whining. If I change the vertical, it goes away there. That's really weird. So, probably what's happening is when the vertical is at the frequency it's supposed to be at, the voltages on that transistor are, well, I mean, at any frequency right now, the voltages on that transistor are not correct, and the voltages on that tube are not correct. When we turn the vertical all the way down, the voltages get somewhat closer, or they're really not as close as they should be. And the vertical output transformer starts screaming. So this is just a really weird thing. So I'll check these resistors and probably see if I can substitute something there. Let's see if we check. Let's unplug this. We can go to resistor mode. So if we check that, let's see, which ones do we need to check? I think 137 is one. 137 should be 820 ohms. So that was this one here. This should be 820 ohms, and it is still a little bit low, but that's fine. We also need to check 135 for 10 megs. So 135 here for 10 megs. So it looks like it's charging capacity. It's a little bit high, but not insanely high. Let's see. We can check 157 and 143 should both be 5.6K. So 157 that's high. 6.12 should be 5.6. 143. Bad. 5.6, 5.9. It's not too bad. So one of those is a little bit high, not hugely high. Vertical hold control is in that circuit, and then also goes to the other side of the vertical hold control. Goes back to something else. Let's take a look at this here. So you have the vertical hold control here, and this is where the base of that transistor comes down, goes through that resistor to the vertical hold control, which then goes down to this line, which has a diode going over to the convergence assembly, and the other side goes through a resistor to this regulated 200 volts. Okay. So, what is this supposed to be, like a resistor divider from 200 volts down to negative 0.6? This thing is just weird. Like, because they have a low voltage power supply here. You can see over here we've got 18 volts. Focusing. We've got 18 volts here and 36 volts here. So why are they using the super high voltages to divide down to these low voltages instead of just picking them or dividing them off the low voltage supply. Just doesn't really make a lot of sense to me. All of this was like Magnavox's attempt at like super avoiding patent infringement lawsuits from RCA or what, but this is just weird design. Yeah, like this thing really bothers me with this vertical bias here. How they're using the regular 280 volt B plus for the plate, but then trying to divide the boost down to like a negative 9 volts. That I just don't see the logic there. Anyway, let me pull that 10 meg resistor and see what it measures out of circuit and see if I have something I can stick in there. Okay, so out of circuit here, this 10 meg guy is measuring 14.4. So that's what, about almost 50% high. This is a 20% resistor, you can tell by the silver band there. So what I've put in is two 4.7s for now, and you can see those measure, get on there, charging capacitor, about over 9 meg ohms. So hopefully they'll be closer to what we need. You can see for now I've just kind of just have them standing off there. So we'll see if that gets our voltages any closer. So let's back this up a little bit, and we will click back on here. Let's plug this in. Vertical still sounds like it's screaming. So let's see now. Our voltage is here. That's good for it. 16, so that's higher. So let's go, let's move this out of the way. Get back to my transistor collector. Okay, that's better, 15.75. Can we adjust that down? 14, so that wanted to be around 15. See, what's our base voltage now? It's -1, so that's still higher than it was. What's -0.6? I'm not sure how critical that is. Let's check our cathode voltage here. It's still too high. So something is still weird with that. Grid 1 is at 5.8 millivolts. Well, that's better, somewhat. I don't think I'm getting a good connection there. That's on the other side of C135. C135. So this side is our 16 volts. This side is, yeah, 23. That's what I figured. That should go. They're good, I believe. I'll go to this resistor. This resistor goes to the grid. Yeah, that's 23. So that's still too high. So is there any adjustment I can do to this that will affect that? No, 22 or higher. That actually sounds pretty happy right there. Vertical stopped whining. I'm going to just lift this up a little bit and take a peek at our screen and see if what we got. Oh, we still don't have that much height. Those are the vertical all the way up. That's more than we had before, I think. I think before that all the way up it was pretty much squashed in the middle. So I think we're on the right track with these voltages being off. I just think we need another theory as to why they're still off. So this voltage here, yeah, see that's too low. But if we turn this, I mean negative 0.6, right? And then when we got that, we've got 11, so that's kind of low. So still some weirdness there. I'm not sure how critical those particular voltages are. They don't really match though. And these are the voltages from the schematic for this set. These aren't taken from the other schematic. But even when that is, right, this voltage here is still way too high. 24, 20, should be negative 9. That's interesting, it goes up, and it goes down again. So that's at one extreme. Now if I turn it back the other way, it starts going up, and then it starts going down. That's interesting. And on this extreme, the vertical oscillator, the vertical output transformer is no longer screaming. Let's see, what's the collective voltage here? It's only 6, that's really low. And that is negative 0.1, so yeah. Still not there. There was that other resistor that was somewhat off. I don't know if that's going to be relevant or not. What should give me a voltage for, actually, well, so the 200 volt xenodiode is on this point, and that's 200 volts. So that should be fine. And then there's a resistor, that's a high value resistor, 560K. Goes down to the vertical hold control. Let's see if I can find that. R149. Let's see. R126. R149 is here. On the other side of that, we have 0.4 volts. So let me shut this thing down again and we'll check that resistor. Even though I don't have a replacement for that, I don't have a 560K. Let me show you what I'm talking about now. So there's a vertical hold control here, which goes down to this line, which goes to this 560K resistor, which goes over to that 200 volt xenodiode. So that's what I measured here, right on that side of the high voltage adjustment control. And that's 200 volts, and that should always be 200 volts because of the xenodiode there. And it's dropped down from the 280 volt B plus to this 1 watt resistor, and it's limited to 200 volts there. So that's fine. This we have to check. Vertical hold control is 15K. I don't think that should matter if that went high because we can adjust it to either end, so that shouldn't be a factor. One of these two was a little bit high. I'm not sure which one. But either way, it would have an effect because it looks like they're taking this 200 volts and then they just have a bunch of these dropper resistors all the way down to ground here. So if any one of these or more of them is high, that would raise the voltage at different places. Actually, if this one is high, it would drop this voltage. And we can get the right voltage here, but it doesn't make the right voltage here, so that's kind of interesting. And I still think there's something messed up with this circuit. Like something here is not drawing the right current or something. So there's two things that I'm thinking about here. Either one, this is supposed to be drawing, a bunch of current to drop this here, or two, this should be providing such a huge pulse out of this transistor that it's somehow driving that negative. I'm not really sure how that would work though, because it's not driving any current into this circuit. But yeah, and there's no reference to ground for the grid, or it's only reference to, there's no reference to ground at all for the grid, because this line that's divided off of the boost source never actually connects to ground anywhere in the circuit, like through a resistor or anything. So that's kind of weird. So I'm going to check that resistor. I'll see which one of these is high, and we'll go from there. So I hooked it back up just to check what the screen looks like, and it looks like we're getting more vertical deflection now, even though the voltage is still on right. So I can adjust this now, so it does fill out the whole screen. It's still not right here. And if I go back and I adjust the height control, see there's like cutting out. So the height control is also somewhat adjusting the frequency somehow. So now the height control turned all the way that way. That's the wrong control. So that's vertical hold turned all the way one way. That's turned all the way the other way. You can see, so this is like the vertical also kind of like crapping out there for a little bit. You can see how crappy the convergence is. See, if I put this in service mode, it looks better there. But here it's like, that's weird. Put it in service mode. Let me turn the brightness down. Turn the brightness down. Put it in service mode. Looks pretty good there, but as soon as the vertical oscillator starts running, it just goes right out of whack. Super weird. Anyway, let's turn the brightness back up so you can see what's going on. That's you can see again, convergence is just whacked out here. Let me try turning. That one's frozen, kind of. Yeah, see, I can bring red and green together that way and we get yellow. How happens if I put it in service mode now? Does that make service mode out of whack? Yes. Look at that. You adjust it in service mode so they're all on top of each other. Blue's a little bit off, but that's all the way down. I don't want to mess with that right now. It looks nice. Turn on the vertical, and they go out of whack again. So this thing is just really weird. So it almost looks to me like vertical hold has more control over height than vertical height does. So see that's height all the way one way, that's height all the way the other way. So even with height all the way up, it doesn't fill out the screen. But if I turn height all the way down and turn vertical hold, I can get it to fill out the whole screen. It's not nice, obviously, but it does fill out the whole screen. That's like right on the borderline of it crapping out. And I think this might be like fold over or something on the bottom. So like the shape of the waveform is completely messed up, but I think we have more gain now that actually fills out the whole screen. Let's turn this up somewhat. So we'll turn up vertical height. Oh, adjust vertical hold. We can get it to fill out the whole screen. Focus seems like it's pretty bad though. Doesn't look like they're in focus at all. Then there's the issue of the convergence being completely messed up by the vertical oscillator or something. Very strange. So I'll have to see what's up with that. So it seems like, because the only thing that we did was change that 10 megohm resistor in the vertical oscillator circuit. So it seems like that has given us enough gain to get full screen deflection now. I'm still not sure. Like obviously, I don't know if this is the right frequency. I have to hook up a signal source and see if we can actually get it to sync and have full screen picture. Part of the problem though is you can see how it pulls in at the bottom before the top. So we still, you can see that right there is about the edge of the top, and look how much space we have on the bottom. So there's still something messed up with centering. I'm not able to center this down far enough. Where's my screwdriver? The vertical output transformer is still screaming. Like I know you're supposed to be able to hear a hum, I don't think it's supposed to be that loud. You go here in centering. So that's up, that's all the way down, it won't go down all the way. So let me collapse this. Stable, that's stable. So in this mode it doesn't look too bad. Well, it's kind of hard to say because the blue's so far down. So that's all the way up, it's all the way down. So yeah, I should be able to, like, because see, if you turn it all the way up, you can tell it's shifted up. When you turn it all the way down, it kind of looks almost centered. I should be able to turn this, move this down like a significant amount, just like I move it up a significant amount. So here on the screen, courtesy of Hog. So there's still something messed up with the centering. There's definitely something messed up with the vertical. And you can even tell like linearity is weird. You can tell how spread out the lines are at the top. Adjusting linearity control doesn't seem to alleviate that, although it does adjust the height. Yeah, you can kind of see how there's like a space in between the scan lines there. I'm not sure if it's coming through on the camera. Yeah, you can kind of see. I see how up here at the top you can clearly see spaces in between the scan lines, and down here you can't. That's the linearity problem. Should be uniform static. Makes it like somewhat better, but really not good. And that just blows the focus so far you can't really see what's going on. So yeah, something is just really weird with this vertical circuit. Really weird. Now it's twitching. You can hear that too in the vertical output transformer. I'm not sure if you can hear it. Kind of like almost like it's revving up or something. It's really weird. I stabilized it. froze again. There's something just really weird with this vertical circuit. I mean, hear by the sound that the height is adjusting the frequency. So is linearity. So basically all the vertical controls are adjusting the frequency, and the vertical hold has more effect on the vertical height than the vertical height control. I really don't think that's supposed to be the case. So if I turn height, so height all the way down, there's linearity all the way to one way. So turning height, let's turn vertical all the way to one way. So that's vertical all the way to one way. Height up, height down. Vertical up, vertical down. Like the vertical height and hold are switched almost. Like they have the effect that the other one's supposed to have. It's really strange. So if I could spend some time just playing around with this, see if I can figure out what is going on with this thing, because this is just weird. And then even if we can get the frequency to be right and everything, we still have the issue of with the vertical oscillator not running, convergence is, pretty decent. For when the vertical oscillator is running, convergence is just whacked right out. So that's going to be a fun one. Well, it will sync to a picture. We got no color though, and the linearity is still pretty whacked out. I can turn the color control, has no effect. Tint really has no effect. So we can just get some sanity out of this convergence for now. Yeah, so it would be not, this is like quite crunchy too. That's moving red that way. Well, both directions move red that way. Reveal that. Green. Somewhat. That moves it that way. Almost just like one of those like 3D, those old school 3D glasses things. Oh, it really does. Yeah, definitely the convergence is messed up. There's something, because the vertical oscillator like feeds into the convergence circuits and for the dynamic convergence, so it's probably messing that up somehow. I'll have to figure that out later. Weird that I can't get red and green to move together at least though. Sure how well it's showing up on the camera, but you can see how stretched out his head is. Vertical linearity's messed up. So at least we know that it will run at the right frequency. This is the right frequency for it to run. So that answers one question. It is running at the right frequency. It's just, something else is messed up with it. It also means that, the sync separator and everything is also working. So how far can we turn this before, well, not that far. tune it somewhat, but yeah, the sync circuits are working. What else is working fine? Vertical will run at the right frequency, but linearity and height and centering are messed up, and convergence is messed up, and color demount is messed up. So yeah, this thing is messed up.